So now what's next? See the next step, this pivotal 3 I divide by 3. That's how I got 1/3, 1/3, 8. And this one, that's not a change. Remember original 24, now it's 8. Now, what is the Gauss-Jordan algorithm? You can do 3 operations. You can use this row to make this 0, make this 0, make this 0, but you need to do the same operation to make all that change. See, this changed, changed, changed. And that one is use the Gauss-Jordan algorithm. And then, especially you made this equal 0. And that operation, let me just do one. How to make this equal 0? Now the new one is 1 here, 1/3, 1/3, and 8. So you add 3 times to here, that's 0. Add 3 times to here, that will be negative 4/3. Negative 1 actually. And that's 1/3 add 3, that's negative 1, 0, 0. And this one is 1 now. And then this one is going to be 8. 3 times 8, 24 actually, 24. 3 times 8, 24. See, that increased. And then you minus 2 of the third row to the second row. The first row minus 2 of the third row, you make this equal 0. And then, I mean in here, 0, 0, 0. See, that's 24. What does that mean? That means you made a significant increase. Here, actually significantly decreased the f to negative 24. All right, what's next? So this will be the 4b. We got another table. We are not going to hold because this is still negative. So automatically, this will be the pivotal element or pivotal column. And the y will be the nth basic variable. How do I find the leaving basic variable? Basic variable. I let the last row 2 divided by 1/3, that's 6. 26 by the 7/3, that will be 78 divided by 7, around 11. And 8 divided by 1/3, that's 24. And obviously the 6 is the smallest one. Then this row is the pivotal row. And the leaving variable is the one, this is not basic. That's the only one basic, because you see the 3, 0. Then this will be the leave basic variable. And what's the pivot element? Let me erase that. So the pivot element is going to be this 1/3. And the y will enter to the game, and s will leave in the next step. So what's next? Next, I want to make this 0, 0, 0, and see what's happening. Also use the Gauss-Jordan algorithm. I will add 3 times of the first row to the third row, to the fourth row. Then this will be 0, and that will be 3, that's 0, and that's negative 2 is negative 1, and the 2 times 3 is 6, add the 24 is 30. So I do 1 to show you how to do it. Now, I'm not going to read this, you can read it later. Okay, here it is. So the y is the pivot element, negative just 1, like Gauss-Jordan algorithm. I made this 0. The question is, now this is 30. Have we done? That's 3, negative 1. So the question is, have we done? Answer is no. You got another -1 here. And this t give you the trouble. So we still have one step to go. I want to make this t non-negative, and then probably we are done. Again, you see, we from 0, the next table is 24, now it's 30. We did decrease the minimum. So one more step. Our pivotal column is right here, because that's -1, you have no choice. And 6 divided the -2, that doesn't count. We don't count the -1. 12 divided by 4 equals 3. 6 divided by 1 equals 6. And then among the 2, and the 3 is the small one, then this will be the pivotal, the pivot element. So I want to make this as 1, and then this is 3, 1/4, 7/4, and then make the last change. Now this is 1, 3, 1/4. What you made, that's 33. Now check. No negative, no negative, no negative, no negative, no negative, no negative. You're good. So we call halting condition is satisfied. And then your job is done. You get your maximum solution. That's 33. And let's see how to read your answer. In this place, basically tell you y equal 12. Can you see it? And the x equals 3. T equals 3. In your objective function, you don't have t. You only need the -3x minus 2y. That will be -24 minus, 2x minus 3y. -24 minus 9, which is -33. That's why you see the 33 here. So you're done. The answer is the maximum profit is 33,000. And your solution, you want to sell 3 tons of the crop A and 12 tons of crop B, as you see the solution. Well, looks like complicated, but the key is the procedure. How do you find such a element? We call it pivot, and then identify the end variable and the leaving variable. Well, you read the example in the lecture notes, and there's 2 more examples there, and you're going to find it. Well, the last thing I want to do is show you a few lines of MATLAB codes you can solve the first example. And we solved it by graphical illustration. This preparation is the same as our 3rd step. Okay. It's the same as this step. We want to identify the C, the B, and the A. Okay. Now look. That's my F. This is the C actually. The 2 coefficient. And the B, 3 constraint. You remember this F equals -99 x1 minus 900 x2. And the first parameter is 0.4 x1 plus 0.6 x2 less than 8.5. And the 6 x1 minus, 3 x1 minus x2 less than 25. And the 3 x1 plus 6 x2 less than 70. So you're going to write this B the right hand into one column or one row. And the A, which is the coefficient matrix, 0.4, 0.6, 3, -1, 3, 6, into another matrix. And that B, don't worry about it, that's the 0, 0, because we don't have equations. Now you write the left hand, that's your solution. F value is your return maximum. And the keyword, linear program. LINPROG. All you need is help, LINPROG. They'll give you all this command that you copy paste. Now what you put? FAB. FAB in order. And this LB, don't worry at this moment, is 0, 0. And this two, don't worry, just put it there. That's how you use the command. Well, the answer is what we see last time, 10.5 round to 11. And the second machine round to 7. And then your maximum productivity is 21,437. Then you solved it, just a few lines of codes. Okay, but if you got a real complicated problem, this flag just to show you what's wrong in the computation, because this could be too big to be managed by the computer. They give you an X flag. If it's 0, typically tell you you're right. Very good. But if it's a negative number, usually tell you it's wrong. Oh, here's 1. 1 means right. You solved it right. Okay, so let me summarize what we did. We showed how do you use linear programming to solve optimization problem. The difference from what we learned in the Lagrange method is you have constraint in equations. Another difference is all your equations are first degree. That's why we call it linear. And when you draw a picture, if it's 2D, they're straight lines. 3D, they're planes. 4D, and there we call it a hyperplane. And you have all those convex holes or convex polyhedrons or convex polytopes. That's how we call it. Then when you solve the equation, and they give you the point, which we call the extreme point, and then the answer, we give you this, we call it the objective function. Well, we used 3 different ways to solve it. We used the graphic method, the manual simplex method, and then we use MATLAB to solve it. The keyword of MATLAB is linear program, LINPROG. Thank you. Tomorrow, we're going to move to another type of linear programming. Today, everything looks perfect because it's all the same direction of in equation. But we have not addressed the equation like big or equal. For example, you want to produce more than how many tons of the food. This we have not addressed. We're going to talk in next lesson. Thank you.